So we will factor by grouping when we have a polynomial expression that has 4 terms. So this expression, 6x cubed plus 54x squared plus 5x plus 45, has 4 terms. So to factor this, we split it into 2 equal parts, and we think about the left-hand side first, and we want to find the greatest factor between 6x cubed and 54x squared. And the greatest common factor between those 2 terms is 6x squared. So what we're left with inside is x plus 9. On the right hand side, I could factor out a 5 from both 5x and 45. So plus 5, I get x plus 9. At this point, we want to check to make sure that these 2 binomials are the exact same. Those binomials are in fact the exact same, so that makes up the first factor. And then whatever's left over, 6x squared and 5, makes up the second factor. Okay, so that's the final factored form. We can check this just by multiplying out. And so by multiplying, we get 6x squared times x is 6x cubed. 6x squared times 9 is 54x squared. 5 times x is 5x, and 9 times 5 is 45. So it checks. We have what we started with, so that tells us that this is indeed the factored form. Let's look at another one here. Still 4 terms, so we can factor by grouping. On the left-hand side, I can factor out a 3x squared, and we're left with, let's make that 2 better, 3x squared. We're left with 7x plus 6 inside the parentheses. On the right-hand side, there's nothing really to factor. It doesn't seem like there's a common factor, so let's factor out a 1, and we're left with negative 7x minus 6. Now looking at these 2 binomials, they're not the exact same, 7x plus 6 and negative 7x plus 6. In fact, the terms have opposite signs. So what we want to do is, instead of factoring out a 1, we want to factor out a negative 1. So factor out the negative 1, we're left with positive 7x plus 6. Now those binomials are the exact same. Because those binomials are the exact same, they make up the first binomial in the factorization, and then 3x squared minus 1 makes up the second binomial. And then we have it.